Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Falinsa Almayda from IPSE 2018. Well, today I would like to explain about Newton's law. So let's get started. So the first one is Newton's first law, and it can be called by the law of inertia. So an object in motion will stay in motion, an object at rest will stay at rest, unless it's bound by an unbalanced force. So what does that mean? Yeah, keep doing what it was doing. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving at a constant velocity. So for example, the soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. So that's an example of Newton's first law. Next is Newton's second law. Force is equals to mass times acceleration. So what does that mean? Means that the force acting on an object is equal to the product of its mass and acceleration. For example, the mass of each ball is different. Each ball will travel a different distance and at a different speed when it is hit with the same force. So that's an example of Newton's second law. So the next is Newton's third law. For every action, there is an equal and opposite reaction. So what does that mean? If object A exerts a force on object B, then object B also exerts an equal and opposite force on object A. Notice that the forces are exerted on different objects. For example, when you jump, your legs apply a force to the ground, and the ground applies an equal and opposite reaction force that propels you into the air. So that was an example for Newton's third law. And now you might be wondering about Newton's law based on integrated science. So Newton's law application in science. In the first one, I will explain about Newton's first law, and I will take an example from bowling. So, a real example of Newton's first law is like a bowling ball hitting the pins. The law states an object at rest will stay at rest until an unbalanced force acts on it. This is like a pins. The pins stay idle on the lane until the ball hits them. Additionally, the second part of the law also states that moving object will continue moving forever at the same speed until an unbalanced force acts on it. This is like the bowling ball. Yeah, the rolling ball hits the pins and creates an unbalanced force which will cause the pins to move because the pushing force of the ball was greater than the pin's resting force. Although the ball had been traveling at a consistent rate, its speed was altered when it came in contact with the stationary pins. So, next there is pushing a shopping cart. For a real-life example again of Newton's second law is a full shopping cart versus an empty shopping cart. In his laws, Newton says that if two objects are pushed with the same force, the object with the greater mass will have a slower acceleration than an object with less mass. Yeah, the law describes that the less mass an object has, the greater the acceleration. This can be related to the shopping carts. If a person pushes two carts, one empty and one full of groceries, with the same force, the empty cart will travel farther and accelerate more compared to the full cart. This can be used as a real-life example of Newton's second law of motion. And for the last example that I take is from a canoe board. When you paddle in a canoe, pushing the water backward with the paddle creates an equal and opposite force that pushes the boat forward. The force pushing you forward is called the reaction force. So that was pretty much it for Newton's law application in science. And we are next to Newton's law application in technology and engineering. So for the first example, I take a rocket. Rocket related with Newton's three laws at work. A rocket taking off shows Newton's law in action. Before liftoff, the rocket's enormous weight, the result of gravity pulling it down towards Earth, is balanced by the upward force of the launch pad, so it remains stationary, or we can conclude it's from the Newton's first law. And fuel combustion in the engines creates thrust, propelling the rocket forward, or second law. The thrust that pushes the rocket forward is a reaction to the hot exhaust gases pushing backward, or as we can call the third law. So the next is diving. Diving related with the Newton's second law, sometimes incorrectly referred to as flippers. Fins are used to aid propulsion when diving, right? The standard fin consists of a shoe made of rubber and a blade made of a slither material, often with ridge and fins to enhance performance. Advances in fin technology mean that there is a wide range for the diver to choose from, depending on their specific preference. So, for example, split fins offer a high degree of agility underwater, but many divers believe traditional models deliver more outright thrust. Your movement through the water should be driven and controlled by your legs. If you watch experienced divers, you will notice that they use their arms very little and more effortlessly through the water, saving energy, minimizing air consumption, and avoiding damage to reef and the marine environment. Swimming with fins should be an extremely efficient way of propelling yourself through the water. So that's it, and the last an example that I take is parachute. Parachute related with Newton's second law, I mean third law, because there are force, mass from object, and acceleration. So that's all from me for these topics. I hope you guys can understand with the explanation I made. So see you guys. Thanks for watching.